Research is being undertaken to see if memory training can improve short-term memory. A student is shown 20 random objects and then asked how many of them she can recall. Over a period, she has remembered 40% of the objects. After memory training, the test is to be re-administered, and the researcher wants to test whether there has been an improvement in memory at the 5% level. Determine the critical region. So, we know here that the null hypothesis would be 0.4, the situation of no change. And because we're looking for improvement, the alternative hypothesis would be greater than 0.4. So we're modeling this based on 0.4 because we always model based on the null hypothesis. Now greater than, so what we're going to do is look for our critical region at the top end here. Now let's go to 12. And we can see that the cumulative probability there is 0.9790. So if we do 1 take away 0.9790, that's 0.021, which is 2.1%. If we go to the next one, 0.9435, 1 take away 0.9435, that's 0.0565, which is 5.65%. So that's too big. We're testing at the 5% level. So our critical region is going to be from 12 upwards. So 12 is the critical value, and anything above 12 is the critical region. And in that region, we would have grounds at the 5% level to reject the null hypothesis.